This here is an LCD screen. It has about 5 cells. Those cells are actually split up into different 8 sort of shapes. This is part of a microwave. As you can see, it has a backlight, and that backlight is a very bright backlight. However, this is an LED screen. It still does probably have a backlight, but instead of using liquid crystals like an LCD display, it uses just LEDs. And it probably has millions and millions of different cells. These are pixels. Now, the phone I'm recording on right now is also an LED. In fact, it's a liquid retina display because it's by Apple. Actually, it's not really liquid retina, is it? So we're going to talk about LCD first. The LCD stands for liquid crystal display. So it uses liquid crystals. Pardon my awful handwriting. That one is actually sometimes how I write. So let's start with these cells. These cells are, well, 8s. And there aren't actually 5 cells on that microwave because there are actually 7 different cells. How this works is that each cell can turn on. So if we want to turn on these ones here, or if we want to display a 3, then we can only turn these cells on and get rid of these ones. And in the end, it'll look like a 3. You might have seen this on some watches before smartwatches like Fitbits and stuff came and conquered them in around 2016. So this is kind of how an LCD display works. Except in an LCD display, you still got those millions of different pixels. And they are actually divided into 3 subpixels. One is for green, one is for red, and one is for blue. I will go down further into detail in another video. So, yeah. So, how do these liquid crystals actually turn on? Well, they're not actually liquid crystals, except there are some liquid crystals in there. And let's show basically what happens. You have a backlight, which can be an LED. This on the microwave was very strong. That's why I said the backlight is very strong. The stronger the backlight, well, the more you can see, the brighter it will be. So then you have light coming out of here. And then you have this vertical polarizer or horizontal polarizer. And what it does is that basically you have vertical light and you have horizontal light. So what will happen is that only horizontal light will be able to go through. So now only horizontal light is going through because the vertical polarizer, or the horizontal polarizer, got rid of all the vertical light. So now what happens? You have the actual liquid crystals. And these liquid crystals are actually kind of like this. They are actually from a bird's eye view. They're like sausages. At least that's what I saw in a video. So now you also have these little things. And now you have the vertical polarizer. And what this does is it removes any horizontal light. And of course you have like a glass filter. What happens is that it removes all the horizontal light, so now no light is getting through. So now how do we cause this to illuminate? How do we get R3? Well, what's gonna happen is that these little crystals are gonna change. What's gonna happen is that slowly, let's look at it from a front view. We have our crystal over here. This is our last crystal. This is our vertical crystal. And you also have another crystal behind this one that is slightly tinted, and it gets a bit more tinted. And now it's like that. So this is the back. Light is going through these crystals, and now they've been turned into vertical light. They went through this polarizer here that turned them into horizontal light. Now the liquid crystals have turned. They physically turned around. These are molecules of the liquid crystals. They turned around, they twisted and turned a bit to make sure the light is now vertical. So now they can get through this polarizer, and now we'll see this. And what happens is that we have a bunch more of these, obviously. So now we get our 3. So these crystals can either stay like this, or they can go kind of vertical. They can be a bit vertical and at the same time a bit horizontal. They can be kind of in the middle. This is how the intensity of the light happens. So basically what you have in an LCD display on your TV probably, you have these pixels and you have subpixels and stuff. Each pixel, it can go from 0 to 255, making it have 256 different values. So let's say 0 is this, 255 is this. So now no light is coming through this. So what's gonna happen now is that we can kind of make them a bit horizontal and a bit vertical. We can make it in the middle so that we can control the intensity. We can let some light go through. You could also do this using the backlight, but honestly you wouldn't really want to do that. So this is how a traditional monochrome LCD display works. And what it actually does with the video card, it actually sends 1s and 0s to these. So a 1 is this, and a 0 is this. So that means a 1 is letting light go through, a 0 is not. So thank you for watching this video on how the liquid crystal display works, and I'll see you later to maybe see the light emitting diode display or the cathode ray tube display. Bye.